Hey, this is Mr. Ayton. Welcome back, Pre-AP Chemistry. We are in Unit 10, Aqueous Solutions. We're going to dissolve some stuff into water for aqueous solutions, and this is week 21. What are we going to learn in week 21? We're going to learn what concentration is. We're going to learn to think really hard. No, that's not the concentration we're looking for. We're looking for how concentrated the solution is, and we call that molarity. Molarity is the concentration of the solution. We're going to take a look at particulate models of solutions, how to do dilutions and how to calculate dilutions, as well as how to prepare solutions and dilutions in the laboratory. So really great unit here for aqueous solutions, and it all begins with understanding concentration. Concentration is called molarity. And of course, when you're making a solution, you're dissolving one thing into something else here. And so the thing that you're dissolving is called the solute. The thing you're dissolving it in is called the solvent. And so you can see, if you take the moles of the solute divided by the liters of the solution, that will give you the molarity or the concentration. We also call this molar, okay? So if you take, to find the moles of a solute, you're going to take the number of grams and divide by molar mass. We know that. Grams divided by molar mass is the moles of the solute. The liters of solution is, we always want it to be in liters, which means if you're in milliliters, divide by 1,000, and that puts it into liters, okay? Which means if we do algebra, the molarity times the liters would equal the moles of the solute, okay? So let's get some example problems in here. You can see here we have a 0.25 liter solution, okay? 0.25 liter solution, which means this is 250 milliliters. So we would want to change that if they gave us the volume in milliliters, change it into liters. We have 77.4 grams of NaCl, and we know the molar mass of NaCl. So what are we going to do with grams first? 77.4 grams of NaCl, always divide by molar mass. We're going to divide by 58.44 grams per mole. Okay, so if we take 77.4 divided by 58.44, we end up getting 1.32 moles of NaCl, Then how are we going to find the molarity? We're going to take the moles of NaCl, 1.32 moles of NaCl, and we're dividing that into 0.250 liters of the water. And that 1.32 divided by 0.25 ends up giving me 5.28 molar of NaCl. Again, we put our units of molar. We could also put units of moles per liter, or we could call that big M, which is molar, of NaCl, and that is the molarity of that solution, okay? Now, let's say we're given the molarity of the solution. You can see here we have 2 molar of HCl. So if I have 2.00 molar, which remember this is moles per liter, we can multiply by the number of liters, 0.350 liters. And so 2 times 0.350 is 0.700 moles, and that's hydrochloric acid, HCl. And so I have 0.700 moles of HCl, because molarity times liters equals the number of moles, because moles divided by liters equals the molarity. Then we have 0.700 molar of HCl, and we can multiply by the molar mass of 36.4, sorry, that is moles right there, 36.46 grams for every 1 mole of HCl. So when we multiply that, we end up getting 25.5 grams of HCl. So that is how many grams of HCl you would need in 350 milliliters, or 0.35 liters of water, to make a 2 molar hydrochloric acid solution, 25.5 grams of HCl. And so we took a look at how to start with grams, get the moles divided by liters to get molarity. That's a divide problem. Or if you start with molarity, molar times liters equals moles times molar mass equals the number of grams. So let's take a look at some particulate models of solutions. We have 1 molar of NaCl here. What would 1 molar of NaCl look like? Well, what do we know about Na and Cl? They break up in solution in water to be Na plus and Cl minus, Na plus and Cl minus, okay? And keep in mind, we don't have to draw the water molecules here, but if we drew the water molecules, of course, the negative side of the water, which is the oxygen, would attract the sodium. The positive side, which is the hydrogens, would attract the chlorides, okay? But here, I'm not really going to show the water molecules here. I'm just going to show the ions. So you can see one particle of each represents 1 molar. So what would 2 molar look like? 2 molar would look like 2 particles of magnesium. So we have magnesium, 2 particles of magnesium ions, because remember they break up. Now for every 2 magnesiums, we're going to have 4 chlorides because there's a 1-to-2 ratio here. So I'm going to have 4 chloride ions here, and that is what my particulate solution of 2 molar of MgCl2 looks like, okay? Because we said 1 molar was 1 particle broken up, 2 molar would be 2 particles, but because there's 2 chlorides, it's double that. 1 molar of something like this, C6H12O6, what do we know about C6H12O6? This is not ionic. This is a molecular substance. This is not an ionic substance. So this would not break up into positives and negatives. This would just be 1 full molecule, okay? 1 full molecule. You can see 1 molar represents 1 molecule, just as 1 molar here broke up into 1 molar and 1 molar of Na plus and Cl minus here, okay? Which means this solution here and this solution here, the first 2 are going to conduct electricity because we have free positives and negatives. This C6H12O6 is not going to conduct electricity because we do not have positives and negatives that are broken up and free, okay? Well, there's a thing called dilution calculations where when we make a dilution, we can calculate how much we need or what the molarity is going to be, and we're going to use this equation, M1V1 equals M2V2. And what is molarity times liters? That's the number of moles. The moles of one thing are going to be equal to the moles of another thing. And so we're going to use this equation, M1V1 equals M2V2. And so let's take a look. Calculate the volume in milliliters of 2.40 molar. So we have 2.40 molar of means multiply of the volume. So we don't know how much volume we have of this. And here it says produces 100 milliliters of 1.68. So of means multiply, 1.68 molar. We've got to make sure we put these together because it's 100 milliliters of the 1.68. Now you might say, Ayton, shouldn't I change this milliliters into liters? You can if you want. But do you see how molar and molar are together, which means milliliters and milliliters are together in terms of units. So this is a pretty easy math problem. It's an inversely proportional math problem. And when I take 1.68 times 100 divided by 2.40, that means my volume will be 70 milliliters of the more concentrated solution of the KMNO4. So we are going to take 70 milliliters of the KMNO4 to make we're putting a little bit of water in. Think about it. If we use 70 milliliters of this really concentrated of the 2.40 molar to make 100 milliliters, that means we're going to need 30 milliliters of water. And that is called a dilution. And that would make the molarity go down to 1.68 molar. So for every dilution calculation, use this M1V1 equals M2V2. So we're also going to take a look at how to prepare solutions in the laboratory, okay? And so this is something you want to know how to do. Let's say we go back to, we are taking a solid mass and we're going to make a solution of it, okay? And we know how many grams we want of it. So what are we going to do is we're going to put this little weigh boat on my balance. I'm going to tear my balance out at 0. And then we're going to put in the mass of whatever solid we're putting in, and we get the number of grams of the solid that we needed, that we calculated. Then we're going to take these grams and we're going to put it in what's called a volumetric flask. A volumetric flask. A volumetric flask has one job in life, and that's to measure to one volume. So let's say we're using a 100 milliliter, 100.00 milliliter volumetric flask. This does not measure 50 mils. It doesn't measure 25 mils. It measures one volume very, very precisely, which is 100.00 milliliters. So we put the solid in here. We put the solid in there. And then what are we going to do? We're going to put in distilled water. Distilled water. So we put distilled water in. The distilled water ends up filling up. And we want to fill up all the way to the volume. We want the meniscus to be right at this little volume. So we want to fill it all the way up to the volume exactly. And then we invert it and mix it and get it nice and dissolved. Okay. And so you can see, well, first we want to dissolve it first, then we move it up to the volume and we mix it. Okay. So a couple different steps: measure your mass, put it in the volumetric flask, which is don't put it in a beaker, don't put it in a graduated cylinder, put it in a volumetric flask, put in distilled water, dissolve it, bring the water up to volume here. Bring the water up to volume. Okay, so that's how to prepare a solid solution, making the solution dissolved in water. Now, we can prepare a dilution in the laboratory as well. So remember, just like when we needed 70 milliliters of the very concentrated KMnO4, okay? And so what are we going to do is we're going to fill up what's called a burette. A burette. A burette is a nice, very precise way to dispense solutions, okay? And so we know what the initial volume is, and we want to make sure, if we wash this out with water, we want to make sure we rinse it out with whatever we're going to put in it, so there's no dilution going on here. And so we put in some of this very concentrated solution. We're going to dispense that into my volumetric flask. Again, I'm going to use another volumetric flask. And let's say I dispense exactly 70 milliliters, exactly whatever the initial minus the final, and we put in 70 milliliters. And we put that all right in here, all 70 milliliters in there. Well, what are we going to do then? We're going to put a little bit of distilled water in there, and we're going to bring this distilled water all the way up to the volume, aren't we? And we're going to, of course, mix it. Okay. So what are we going to do to prepare a solution in the laboratory? Well, we measure the mass, we put it in a volumetric flask, we dissolve it, we bring the water up to volume. What about making dilutions? We're going to put whatever our concentrated solution is in the burette, we dispense it, then we fill it up with some distilled water, bring it up to volume, mix it, and we have created a solution. Well, that's Unit 10, Aqueous Solutions, Week 21, Pre-AP Chemistry. I'll see you in class. See you guys. Bye-bye.